All right, so this is 41B, and this is factoring a sum or difference of cubes. And so this is what I don't know if we did this in class yesterday or not, but this is a continuation of factoring. So the two strategies that we did in 4.1 was a GCF, which is our greatest common factor. And when we had something that was a greatest common factor, you can have any number of terms. It doesn't matter. And remember, with a GCF, this can be a number, it can be a variable, or multiple variables, or it could be both. Okay, super important. And then the other one that we did was a difference of squares. And this only has two terms, and it's only a difference. So we would have a perfect square minus a perfect square. Right? That's the only way it works. If it was an addition problem, it doesn't work. Okay, so just a little quick practice based on what we did in the last lesson. We're going to look at this. Is this a perfect square? And this is a perfect square. I cannot pull out a GCF. Remember, GCF is always the first thing that we look at. So because I can take the square root of this, I can take the square root of this, I'm going to use my special pattern, which is x plus 10, x minus 10. Okay, so 49, cannot pull out a GCF. This is a perfect square, this is a perfect square, so I'm going to use my pattern, 7 minus x, 7 plus x. Okay, let's go down here and look at number 4. I have 3 terms, so no matter what, I cannot use a difference of squares, no matter what, because I have 3 terms. So I do have a greatest common factor. I can pull out a 5, 5, and 5. So I'm going to pull out a 5. I see I have an x squared, I have an x, but there's no x here, so I can only pull out the 5. So what's left is x squared minus 4x. Remember, 5 times 4 is negative 4, actually is negative 20. And then I look at the last term, plus 5. Okay? Go ahead and pause the video and do 3 and 5. All right, so perfect square, so I use my special pattern. This one's a little more complicated, right? So you have x cubed, x squared, x, so I pull out an x. I would check this one. Oh, see, good thing. I was going to check it because I forgot this 4 right here. So when I check this, I would have 8x cubed, so that's right. I go to this middle one, I'm going to have 4x squared, so this is right. And I go to the last one, negative 10x, so that's right. So just like that, I would always go back and check. Okay, so now we're going to look at another pattern. So this time we're going to look at difference of cubes. All right, and our difference of cubes is also going to have 2 terms. Now, actually, hold on, I'm going to change this because I just noticed this. We're going to have difference or sum of cubes. So this is important right here. So we know what a cube is. A cube is anything that's cubed. So 1 cubed is 1, 2 cubed, this is 2 times 2 times 2. So this is 8. 3 cubed, so 3 times 3 is 9. 9 times 3 is 27. Okay, so 4 times 4 is 16. 16 times 4 is 64, sorry. And then 5 times 5 times 5 is 25 times 5, which is 125. So you need to know those. You need to know these. Now, we have a special formula, and I'm going to talk about the formula here for a second, and then I'm going to give you a couple of shortcuts for this. So this should be subtraction right here. And so I have, I'm going to give you these. Let's just write this down, and then I'll talk about it. All right, so my formula is a, b, and then have new parentheses, a squared, ab, b squared. So my first factor is a, b, and then I have a squared, ab, b squared. Now you notice I have all of these spaces in here, and this is where my signs are going to go. So I have a little corny thing that I do when I do a sum or difference of cubes, and it's called SOAP. So when you hear me say SOAP, you know that this works for a sum or a difference of cubes. Now here's what it stands for. The S stands for same, the O stands for opposite, and the A stands for always, P is positive. So here's where this comes in. If you can remember this pattern, AB, A squared, AB, B squared, you just got to memorize this pattern, just like this. This only works if this is a perfect cube and this is a perfect cube. So this is addition. So if this is addition, I'm going to use the same sign. So same sign would be addition. The next space that I have right here is going to be the opposite sign. My opposite sign is subtraction. And then my last space down here is always positive. So if this one is subtraction, I'm going to have same sign, so subtraction, opposite sign, which is addition, always positive. Okay, so let's put this to practice here, see how this works. So I have two terms. I have a cube and a cube. So my A term is going to be this first one, and my B term is going to be the second one. So my A term here is going to be the cube root of x cubed. So the cube root means I have three of them, x times x times x. Well, I have three of them, so my A term is just x. And my B term is the same as the cubed root of 27. So this is the same as 3 times 3 times 3. That's why these are imperative. You've got to know these. So that means my B term, I want a grouping of 3. I have a grouping of 3. So my B term is just 3. So first thing we're going to do is look at our pattern. So it's A, B. I'm not going to deal with the sign right now. So x, 3. This is my A term. This is my B term. Okay, start my new parenthesis. My pattern says x, or my A term squared. Well, that's x. So this is going to be x squared. The middle term is AB multiplied together. So this is going to be 3x. Now, I could do x3, but we know that the number always goes before the variable. So just change it when you write it. It's multiplication. You can change the order. And then the last term is b squared, which is 9. So A, B, A squared, A times B, B squared. Now I'm going to go back and do SOAP. I'm going to do my signs. So first one is same sign. If this is addition, this is addition. Opposite, always positive. So this is my final answer. Now, what it's important to see is because this is addition, I can do this only with cubes. So that's why up here we say sum and difference of cubes. Now, when I did difference of squares up here, perfect square minus perfect square, this only works if they are squares and they're both perfect, but it has to be subtraction. All right? Don't get confused because down here, crooked. Down here, this also works, sum or difference of cubes. So it works with addition. Okay, let's do one more together. So 64, so the cubed root of 64 is going to be 4. But I have a variable, the cubed root of A cubed is A. And the cubed root of 125 is 5, right? If you see these up here and you memorize these, this makes this easy. Okay, so pattern, A, B, A squared. So A squared is going to be 16A squared. So I have to square both of them. I square the 4 and I get 16. I square the A, I get A squared. My middle term is A times B, so 20A. And my last term is B squared, 25. All right, so now I'm going to go back and do the signs. So it's same, opposite, always positive. Okay? Come see me if you need more practice in class.